that is one of the functionality in your transport layer. Where does this transport layer occur? After session layer and before network layer. So this is all in your OSI model. In TCP IP protocol, in OSI layer there are 7 layers. So it occurs between session layer and your network layer. In TCP IP protocol, there are only 5 layers. So where does this occur? Application layer. Below application layer and above network layer. So these 4 layers are common both in OSI and TCP. So in data link layer, how your data is transmitted? Frames. And in your network layer? Process to process delivery. In your data link layer, it is of node to node delivery. What is a node? Any device that is going to transfer data. It is node. So that uses MAC address. What is host to host delivery? It is in the network layer. Network layer follows host to host delivery. What is it? Any system or node that is connected to a internet is called as host. So that is going to be of your host to host delivery. And now in the transport layer, it is process to process delivery. So in an IP address, some applications are running. So those are called as process. So those applications are called as process. And here it is going to be of process to process delivery. So this is your internet, and first the data link layer, it will be of node to node, and then your network layer, it is host to host delivery, and in your transport layer, it is of process to process delivery. Client server. Have you heard of this term, client server program? Who is the client? Who needs some things to be done? Called as client. Who is the server? Who provides the? So that mechanism is used in your transport layer. It is of client server parallel. So a process on a local host is called as a client, and next is addressing. What is addressing? We have seen in data link layer, we have seen in network layer. So data link layer, how will your address be? In data link layer, what address you use? NAT address. And in your network layer, IP address. And here you will be using port numbers, port address. So port address is something that runs on the IP address. So if I am running an application, for example, I am opening some web page and running. So it will have a specific port number. It runs on IP, but it has a specific port number that is called as address. So here it is of port address. So your port address is from 0 to 65,535. Within this, it can be of any numbers. So in a client can automatically itself have some address. It can define its own by its own port address, but server cannot do that. Server uses well-known port addresses. So we will see what is well-known port address. So IANA is Internet Assigned Number Authority. It just defines your port address in 3 different types. First is going to be well-known ports. Second is registered ports, and the third one is dynamic port. So your well-known port ranges from 0 to 1023. So that well-known ports are already predefined. If your port is running on 0, it has some definition for that. If it is running on 11, it has some definition for that. So they are known as well-known ports. It is assigned and contributed controlled by IANA. Next is registered ports. Registered ports are from 10242 to 49,151. They are not assigned and also they are not controlled by IANA. And the third one is called as dynamic ports. So dynamic ports are only acquired by clients. So servers run on well-known ports and clients run on dynamic ports. So it ranges from 49,152 to 65,535. See, this is your client and this is your server. Here there are 3 different packets and these different packets run on 3 different ports. So this is the port address for your server, and here this is a server and it has 3 different packets. So 13 is your port number in the server. So if it comes under 13, what types of port is it? So it is a well-known ports. Next is socket address. So combination of your IP address and your port number is called as socket address. So why we need an IP address in transport layer? So in your IP address only you will be running the processes. So for example, see here, this is your system and this system has this IP address. So here the IP address is mentioned and the port number is 13. That 13 runs inside the IP address. For example, this machine will have different IP address, right? In this machine I am opening it, I am opening Google. In Google I have opened 4 different tabs. So for those 4 different tabs we will be having 4 different port numbers. Understood? So in a single IP address we will be having n number of processes. multiplexing and demultiplexing. So you all know what is multiplexing? We will be combining multiple items and then the result as one. Here, in a particular system or node, whatever it is, there will be multiple processes running on. So those processes will be multiplexed and then sent in the IP. In the server, it will be demultiplexed and then given to those systems. Connectionless versus connection oriented. What is connectionless? You have all seen this. What is connectionless? There won't be transmission. That is connectionless. And what is connection oriented? You will be having a table, that's it. So here your transport layer protocol is of both. We have three different transport layer protocols. So first is UDP, TCP, STCP. Your UDP is user datagram protocol and it is connectionless. And the other two are connection oriented. Next is reliable versus unreliable. So here also your transport layer protocol can be reliable or unreliable. So if you want to add some error mechanisms to your transport layer, you can add. So they are called as reliable. And if you don't want to add the error mechanism to your transport layer, then it is unreliable. It is up to your wish. If you want to add an error and flow control mechanism, you can use protocols according to that. If you don't want to use it, then it is unreliable. See here. So till data link layer we have error control. We have mandatorily in our frames. In the network layer we have that no. And so here these are error is checked in the paths. But in the transport layer and network layer the error are not properly checked. So it is our wish to add error and flow control mechanisms. This is your TCP/IP protocol. So in TCP/IP you have 5 layers and see the position of your 3 different types of protocols. One is going to be UDP, TCP and STCP. So first we will see user datagram protocol. User datagram protocol is one of the simplest protocols in transport layer protocols. So it is connectionless. There won't be any medium in this, and it is also unreliable. Unreliable means will it have an error or flow control? Will it have error or flow control? No. So your UDP does not have error or flow control. So here your UDP protocol will not have any extra services. The need of your UDP protocol is only to transfer the data. It will not provide any extra services. See in Unix, your well-known ports are stored in this file. When you are giving the command, you can get your well-known codes in Unix /etc/services. These are some of your well-known codes, and that is your port number, their protocol and description. So if your process is running on port 13, that is daytime, then it returns the date and time. If it is running on 67, it is server port to download bootstrap information. So these are predefined. Your well-known codes are predefined. So according to your use, you can choose your ports. So here, this is the format of your user datagram. So first it consists of header and then your data. In header what are there? In header what are there? Source port number, destination port number, total length and your checksum. So what is source port number? Destination port number is someone who is going to receive the package, process, and the total length. So that is total length of your header. And next is checksum. Checksum is an error detecting mechanism that is used. What will be your UDP length? The total length minus your header length is called as UDP length. UDP is user datagram protocol length. Checksum calculation. So this is your checksum. So what happens in your checksum is this. First, the 32-bit source IP address will be given, then the destination IP address, then all zeros, 8-bit protocol and your 16-bit UDP total length. This is the pseudocode for checking your checksum. Next is header. So first is going to be your source IP address. We are dividing the source IP address into two types. Next is destination. We are again segmenting the destination into two parts and we have written the binary notations for that. Then all zeros. Then the